We're asked to solve for the given variables, right there, and we have a pair of simultaneous equations. There's a pair of equations right there, and we've got unknowns in both. So these are the given variables. We've got x, y, x, y. For these kinds of equations, the value of this x is exactly the same as this x. The value of this y is the same as this y. And when we come up with the value of x and the value of y, it makes each of these equations true. Okay, so how do we go about these kinds of equations? One of the things that we should really do as a matter of course is when we get questions like this, we have a quick look, we identify their simultaneous equations, and then the next thing to do is just so you can get your head around it, is this a simple basic one or is it a little bit more tricky? And the place to look for that is look at the coefficients. So here we have 5 and 7 in front of the y. And here it doesn't look like there is anything, but of course this is algebra. We don't write the number 1, but there is a 1 here. There's a hidden or secret 1. More than that, that's a positive, that's a positive. These are positive ones in front of the x. Now, if they are the same coefficient, great, that's simple. If they're not the same coefficient, it's a little bit trickier. So 5 and 7, even though they're both positive, they are not the same. Requires a bit of work to make them the same. With the coefficients in front of the x, even though we can't see them, we know it's positive 1 because it doesn't show a negative in front of the x, and when they're both negative and they're both positive 1, so that's a good thing. Both positive, both the same. Yep, it's a pretty simple equation. So what comes next? Next, again, it's just a way to just get your head around the whole problem. We number the top equation number 1 and the bottom equation number 2, and essentially from here it's equation 1 minus equation 2. So let's do that right now. We've got x minus x, 1x minus 1x. Well, that's no x's. It cancels out. There's no more x's. We have positive 5 minus positive 7. So that's 5y minus 7y. Okay, so that's going to equal minus 2y. So let's put that down. And on this side, we've got 20 minus 24. So that's going to be minus 4. Okay, so we've got that. Let's keep going. We should be able to solve. You can see we're at a very simple linear equation state. Some of you may already be able to see the answer. Minus 2y. Now, what does that mean? Minus 2y. That actually means minus 2 times y. But in algebra, we keep the multiplication symbol that is there between the coefficient and the variable. We keep it hidden. Okay, so you have to realize that that's actually there. So how do I cancel or get rid of multiplying by negative 2? Because I want to be left with this y. Well, this y, a positive y, has to equal a value. So the opposite of multiplication is I divide. And the opposite of multiplying by negative 2 is to divide by negative 2. In algebra, we don't really use the division sign like that. So what we tend to use is the fraction bar, because that also means divided by. So minus 2y divided by minus 2. Got to do the same to both sides. That keeps the whole equation balanced. It looks like that. So multiplied by minus 2, divided by minus 2, cancels each other out. I'm left with y, which is exactly what I need. Minus 4 divided by minus 2. Remember, negative divided by negative equals a positive. So negative 4 divided by negative 2 is 2. Okay, so now it looks like I know the value of y. To figure out the value of x, I just substitute it into either one of these equations. I want to take the top one because the coefficient in front of the y is smaller in the top one than the bottom one. So I want to rewrite it here. And I want to explain every single step. So we're going to start with this. X plus 5y equals 20, right? So that's the same as what we started with there. And now I want to substitute the value of y because I know what it is. So x, that hasn't changed yet, plus 5, not times y, but times 2, because I already know that it is a 2, or I think I do, equals 20. And now I'll just simplify to tidy it all up, so I still haven't touched this x, plus 5 times 2, what's 5 times 2? That's 10, equals, and I haven't changed that side. Now, I have a linear equation that I can solve. I need to end up with x being by itself, equaling a value, and I'm almost there, to be honest. So how do I get rid of this positive 10? I do the opposite, which is to subtract 10. I've got to do the same to both sides. That cancels out. I'm left with x all by itself. 20 minus 10 is 10. So this must be the value of x. Now, what I should do is I should check. And I check by substituting back into the original equations. So it's not x anymore. It's positive 10. And it's not y anymore. That's positive 2. So it looks like this. 10 plus 5 times 2. Positive 5 times 2 is positive 10. So 10 plus 10 is 20. Yes, that is correct. This one down here, it's not x, remember. It's positive 10. And it's not 7y, it's 7 times 2. Now, 7 times 2 is positive 14. So 10 plus 14 is 24. That is correct. Therefore, yes, for sure, x equals 10 and y equals 2 are the correct values.